In this section, we're going to introduce you to some geometric concepts and notation. Some of that you might already be familiar with. If you look at a point, you can represent that as a dot on a paper, and we write that with capital letters like P, Q, R, and so on. If you take any 2 points in a plane, then the line that passes through those 2 points is represented with this notation. The arrows pointing in both directions shows you it's a line. A ray is part of a line that lies to one side of a point, and that's called a ray, and this is the notation. You can see how it's all the points that are this direction towards Q. P is called the vertex, or the start point of the ray. Line segment is basically part of a line also that lies between 2 fixed points. 2 lines are said to be parallel to each other, and the notation is L, the double backslash M, showing you that 2 lines are parallel to each other. L and M are parallel to each other. You can see from the grid. If we didn't have a grid, you might have a little harder time distinguishing between parallel and lines and not parallel lines. All right, let's talk about angles. An angle is defined as the amount of rotation between 2 rays that have the same vertex. One way to measure the amount of rotation between the 2 rays is by using the units of degrees. If the amount of rotation is less than 90 degrees, we say that the angle is acute angle. So in this case, this will be an acute angle because it's 34.10, which is less than 90 degrees. So acute angle is angles that measure less than 90. If the angle goes exactly 90, then it becomes a right angle. If the angle is more than 90, it becomes obtuse angle. So this will be an obtuse angle, and you can see that this is right angle. So right angle means exactly 90, obtuse angle is more than 90, and acute angle is less than 90. To measure an angle, we can use a utensil called protractor, and to do that, we just place the protractor so that the little dot on the protractor aligns with the vertex of the angle, and then you just measure it. So for example, let's look at this measure. You're going from 0, 10, 20, 30, 40, 50. So this is 50 degrees right there. 2 lines are called perpendicular to each other if the 2 lines intersect each other at 90 degrees. And this will be the notation for L with this symbol. M means that these 2 lines are perpendicular. All right, we're going to now discuss some polygons. Polygons are closed figures. Let's start with triangles. Tri means 3, so 3-sided closed figure is called a triangle. Any triangle that has one 90-degree angle, like this blue triangle here that you see, is called a right triangle. So a right triangle is one that has 90-degree measure in it. So this is a right triangle. We use this little symbol telling you that it's this angle that's 90 degrees. So whenever you see this square symbol in a triangle, that means that that angle is 90 and it's a right triangle. Take a look at this triangle now. If you look at the angles in here, these are all less than 90. When that happens, you say the triangle is acute. So we have acute triangle, which means all 3 angles that you see in it are less than 90. Obtuse triangle is one in which one of the angles is above 90. So right now, for example, this triangle is obtuse because why? Because this angle right here is 123.17 degrees, so it's an obtuse. So right now, this triangle will be an obtuse triangle. If you looked at all the 3 sides, irrespective of the angles, you will see that when all 3 sides are of different length, they are called scalene triangles. So here we have scalene triangles. So you can have an acute triangle or obtuse triangle. You can also have right triangles that are scalene triangles. We're only asking you to pay attention to the terminology so you recognize it when they are used. Let's look at some special triangles. Here we have an isosceles triangle. Isosceles means 2 of the sides are of same length. And so, for example, here's an isosceles triangle. All right, we can also have a triangle with all equal sides, and such a triangle is called an equilateral triangle. We can make an isosceles triangle into an equilateral triangle by moving the sides and adjusting these lengths here. So this is an isosceles triangle that is now also an equilateral triangle. It has all three sides of equal in length. Right, so here's an isosceles triangle. All right, some other polygons that we're going to look at. Quadrilaterals. Quad means four. So we have quadrilateral as a four-sided figure. A rectangle has all four right angles. Quadrilateral in which all four angles are 90 degrees is called a rectangle. So here's an example of a rectangle. Quadrilateral with all four right angles and all four equal sides is called a square. So here is an example of a square. You can see that I can make a rectangle into a square. Trapezoid is a quadrilateral where exactly one pair of lines is parallel. Other types of polygons that we might encounter are hexagons. Hexagons are six-sided closed figures. A regular hexagon is a special type of hexagon where all sides are equal in length. Let's take a look at circles. If you look at all points that are exactly the same distance AB away from A, then you will get a circle. So all points equidistant from a fixed point form a circle. A is called the center of the circle, and the length between AB is called the radius of the circle. So if you take this point here and you look at all points that are exactly the same distance that B is from A, then we have a circle. Vertical angles. If you take two lines that intersect each other, they form four angles. The angles that A and B are vertical angles, opposite from each other. So are C and D, vertical angles. If you look at two angles that add up to 90, then we say they are complementary angles. So these two angles are complementary. B is called the complement of A. If you look at two angles, the A and B that add up to 180, they're called supplementary angles. And those are angles that add up to 180. All right, these next, you just have to make sure you understand what the terminology is so that when we show you angles, you should be able to pick out corresponding angles and the other terminology that we're going to discuss. Corresponding angles are defined as follows. Angles that lie to the same side of the transversal and to the same side of the lines. So for example, 1 and 5 are to the right of the transversal, and they're both above the lines. So 1 and 5 is a pair of corresponding angles. So are all the other angles that are listed here, you can see. So for example, 3 is corresponding to 7 because 3 and 7 are under the line and to the left of the transversal. So here are some other pairs. All right, let's take a look at alternate interior angles. Angles that lie on the opposite sides of the transversal, but on the inside of the two lines. That's why the word interior. Alternate, so they are on the opposite sides of the transversal. So 3, 5, 2, 8 are both pairs of alternate interior angles. Let's take a look at alternate exterior angles. Exterior, so you can see how 4 and 6 are alternate exterior angles. Again, they lie on the opposite sides of the transversal, but they're on the outside. You see, that's why exterior angles. All right, so here's your homework.